Uh, Good afternoon. I hope everybody is okay, and I hope all of you can hear me clearly. Right? I believe you can all hear me. So, today I don't want to waste your time. I just want us to learn about method overloading, or we can say function. I just want us to learn about function overloading. Remember, for the past, I think 2 3 weeks, we have been talking about these particular things known as functions, right? We tried to describe what functions are, how they work. I tried to give you some exercises on some of these things, and you guys now have a little bit of understanding when we are talking about such kind of stuff. However, we must understand that it does not end there. In other words, we have to continue and learn more and try to understand uh, what other or what the other things which are part and parcel of functions. Right. When we are talking about function overloading, we are trying to say we can have multiple functions that have the same name with different parameters. Let me repeat that. We are trying to say, or let me just text it. We are trying to say we can have uh, multiple functions, right? We are trying to say we can have multiple functions, right? With the same with the same with the same name, but different different parameters, right? I have explained to you guys, or I have shown you how to write, for an example, a simple function. I said when you write a function, it can be like like it can be like that, right? That's how you can write a simple uh, function. However, inside here, we can just put something like int x, just like that. So what does it mean, or what is the meaning of this? We all know that this is a data type. This is the name of the function. This is the parameter, right? This is what we call a parameter. So when we're talking about function overloading, we are trying to say we can have multiple what functions, and with these multiple functions, they can have what the same name but different parameters, right? For an example, when we are talking about, for example, the area, we can say, okay, we want to have a function that will calculate the area of a square. We all know that all sides of a square, they are equal, right? Then we can also want to calculate the area of a rectangle. We all know that this side and this side are equal. This side and this side are also what? They are also equal. So it is important, or it is of importance to take note to say there's no need to write a function which will handle, let's say for an example, this only, and another one that will handle that. No, we can use the same name, yet we have what? Different parameters. Whatever that we're going to place inside is just going to be what? Just going to be different. So that's the whole idea of what of working with function overloading. However, these function overloading things, they only, or they are advisable uh, to be used on small programs, on small what programs. In large programs, you might realize that it might not really, favor you. But for now, I want us to just look, or to continue to look at some other examples so that you can understand. Don't forget the definition that I just gave you now. To say the definition is all about multiple functions can have the same name with what? With different parameters, right? We can have the same name but different parameters. When we deal with that, we're trying to say we are overloading what? Um, a method. So let's try to see what I mean by having an overloaded method. For an example, we can have the first method, function to say, but it's still the same thing. So, which is like that. That is the first one, right? Then we can have the second one, which is like that, and then uh, just like that. Already you can see we are having multiple what functions, but using the same what, the same name. And then the only thing that is different is what? It is what is inside the arguments, inside the parameters. Let's continue and have another example. We can also have something like float, then we have test, then we can have double, let's say a, can have something like that. Also, this is part of what? Of method what? Overloading, as well as we can have int, this example, int test, then int a, then now b, then we can have it like that. All these, they have one thing in common. What is common? The function name, as you all can what? Can see. The only thing that is differing is the parameters, right? So all these included here, it's what we call what? Method overloading. It's all we call what? Overloading. But I want you to notice something. I want you to notice that all these four functions, right? Their return types of all these functions are not the same. So overloaded functions may or may not have different return types, but they must have different what? Arguments. They must have what? Different arguments. Let me repeat that. Overloaded functions may or may not have different what? Return types, but they must have different arguments. So that's what I wanted to just clear, right? That's what I wanted to just clear to you guys. Let me repeat that. All overloaded functions may or may not have different return types, but they must have different what? Arguments. All right, for an example, let's say we have a code like this, int test, right? Then we have int a, then just place it like that, right? And also we have a code which is like double test, then b, then just like that. Oh, all right. Now I want you to look at the two. I want you to look at the two codes. This code, when you run it, this one. Let me just change the color. This code, when you run it, it will give us an error. And then why will it give us an error? Why will this give us an error? I want you to answer me. What you can do, you can just mainly, comment on the comment section right there. So you can now explain to me, why will this code bring out an error? Class, over to you. You can just text on the chat box right there to try and make us understand why will this code give us an error. Hello, are people there? Tawang, my dear. Yes, you can just you know what you can do? Just type on the chat box there. You can type on the chat box. You see, the process of muting, it will give us a lot of chow a lot of time, so that's why I've muted everyone, as well as we are I'm also live on YouTube, so that this video can can stay on YouTube for future reference. Whenever you want to go and reference, you can go and reference on YouTube. So I'm doing it uh, two-way. I think because they have the same argument in exactly because of this argument, right? The code will give us what? Will give us an error. So at all times when you're dealing with function overloading and all this, can make sure that the arguments are different. The name, yes, you can use the same name. So you can actually create a method to say, okay, this is the method. We just name it area. But where it differs now, it might be, okay, you want to calculate the area of what? Of a square. You want to calculate an area of what? A rectangle and stuff like that. So you know that, okay, the first area will take how many parameters? Based on the formula, right, of calculating the area of a square. So you know that the parameters have to feature something like that. Then as well as when you're dealing with a rectangle, is what? It's all the same thing. So that is what we call method overloading. That's what we call method overloading, or we can call it what? Function overloading. I hope we are still together. All right, let's continue. Let's continue. Right, now that we are done, I'm done with the part of explaining this. I think I'm just trying to look if we can get a simple example that we can try to code, and then as we are coding, then we try to understand how this function overloading they actually work. All right, we can do it quickly. Let me just open my development, my IDE, my code blocks, so that we can just code something simple, not something that is hard, but something that is just simple, to try and make you guys understand what we are dealing with. Try and make you guys understand what we are dealing with. Just give me a moment. My code blocks is still opening. I don't know why it's taking time. All right. All right. All right. Code blocks is now open. I believe all of you can see my code blocks. So the first thing that we do, we create a new project, console application, and then dealing with C++, and then we just name it demo, right? We can just name it demo. No, okay, demo 1, so that it then we can click on what? On finish, then just click on sources. Right, there we go. We've got our ID ready, and then what we need to do right now, we just need to code a little bit so that I can try and explain to you guys the concept of what? The concept of method overloading, how it actually, how it actually works. So, all right, let's begin. Let's say, for an example, let me just erase that. Let's start from like that, right? Let's say I'm creating a function. We'll just name it. What can I name it? Okay, we'll just say add, right? Just like that. The function name is add. Then we can have int x and int y, just like that. Then what we can do, we'll just quickly, then let's return x plus y. I've already explained to you all these things that I'm doing. So we can also have double what? Add, right? Then we can have double x as well as double y. Then we can just return x plus y. So remember, based on the definition of method overloading, we said the parameters must be what? Must be different. And as you can check, the names of the function are still the same. And then I told you and I explained that it does not matter. It does not what? It does not. It does not matter about the return types, right? It might or may not. Yeah. So it does not really matter. So right now we've got our our two functions. Oh, sorry, I made a mistake. We should declare these two functions outside the main method, right? That's my mistake. So yeah, we all make mistakes. So after that, what we need to just right now, we just need to what to display whatsoever that will be on these two functions. And so we can say int, let's say just do it like that, same as what are we going to add? We're going to add, let's just think of two numbers. Let's just think of 5 as well as what? As 10. I have explained how these things work. On our last class, I explained what I'm doing here, what is happening here. So if you don't know this, refer or go and get help from your friends. So you can have that, then the name of what? Of the function. So since here it's double, we can use what? We can use let's say 5.5 as well as 6.34. Right. So there we go. We've got those particular things in hand. So right now, I want us to continue and try and display the values, the final answer of these two. Right. So we all know we use cout, right? Then we can just inside put in what? Okay. My num1. All right. Then here we can just put my num. All right, just like that. Then we can have another print. Then we can have my num2, and then it should be like that. All right. All right. So let us continue. Let's try to run this program and we'll try to see what will be the output. So we debug it. All right. As you can see, we have an error somewhere. So all we just need to do is just I think we have an error here, right? We displayed the same thing. That's why it's giving us whatever that it was giving us. So right, let's terminate this. And we just try to run it again. Wonderful. Unfortunately, you cannot see it clearly, but let me try to share. Let me try to share the output. All right, this is the output, right? My num1 is 15, my num2 is 11.84. My num1 is what? 15, and then my num2 is 11.4. Where are we getting that? we are getting that here. We are getting here. We are getting it here. I was just trying to explain the concept of what? Of method overloading. So this is what we call method overloading. It's a principle where now you can what? You can use the same name but different what? Arguments. So this is a method to add what? To add integers as well as to add what? Double. So it's very important for you to take note of that. Very important for you to take note of that. Any questions up to so far before I move on to the next thing that I wanna talk about? Do we have questions? Okay, it seems as if we don't have questions, so we can continue. So in C++, we've got what we call the storage class. In C++, we've got what we call the storage class. So I want us to also look at what we call the storage class. Let me just write it on top there. We've got what we call storage class. You will understand in just a moment what I mean by storage class. So every variable in C++ has got two features. Every variable in C++, right? It has two features, of which the first feature is its type, right? It's type. It's type. Then the second, we've got what we call the storage class. So the type specifies the type of data that can be stored in what? In a variable. So the type, what it does, it specifies the what? The data that can be stored in a variable. For an example, we can have int, float, char. It's more like a data type, right? So, and then when we are talking about the storage now, the storage class controls two different properties of a variable. Number one, we can have lifetime. It determines how long a variable can exist, and as well as the scope, which determines what part of the program can access it. Let me write it this way. The storage class, right? It controls two properties of what? Of a variable. And then the first property that we have is what? It's what we call lifetime. And then the second property that we have is what we call the scope. The scope, right? So when we are talking about, let me again explain what I mean by lifetime. So this, when you are defining life, it determines how long a variable can exist. But with the scope, it only determines, or it determines which part of the program can access it. So this is what we call the storage class. Now, depending upon the storage class of a variable, it can be divided into four major types. Depending on the storage class of a variable, it can be divided into four classes. The first class, or the first type, is the local variable, and then we've got, okay, let me just try to write it down. We can have the local variable. Secondly, we can have the global. We can have the global variable. Thirdly, we can have the static local variable, and then we can have the register variable, and then lastly we can have the thread local storage. We can have the storage, the thread local storage. So all of these, they are different. They are not the same, and I'm about to explain to you in just a moment. I'm about to just explain to you in just a moment. So very important for you to to take note of this. So when we're talking about a local variable, you guys know what a local variable is. A local variable, it is a variable that is defined inside a function. It is defined inside the function, right? So we call it a what? A local variable. So its scope, it's limited to the function where it is defined, which means that when it goes outside, or it is out of what, of the, what do you call, out of the function, we can't name it to be, or this is a what, is a local variable. Its scope has been what, it's out. So let me just quickly show you an example of what I mean, because some of you might be wondering, hey, what is Sir talking about? We don't understand. And let me just open code blocks first. I try to show you what I mean. Okay, let me share my code blocks. All right, there we go. We are back on code blocks. So when I'm talking about this local variable, as you can see, this value here, this is a what? A local variable. Why is it a local variable? It is a local variable because it is defined inside what? The function. It is defined inside what? The function. So the moment you take this outside the function and you place this maybe out there, it is no longer a local what? A local variable. So hence, going back to the definition, we understand that its scope, it is limited to where its function is defined. Its scope. So you cannot, for example, what they're trying to say, you cannot actually access. Okay, I'm trying to think of a simple example that I can give to you guys so that you can catch fast. Right. We are trying to say, for an example, we have something like this, and then we have defined something inside. So we are trying to say this is local because it only belongs here. Just like how your taxis work. You see, they are what we call local taxis. A taxi that roams around Chakuma, right? A taxi that roams around Chakuma, or its certificates telling that Chakuma. If it starts picking up people from Loistreshad or somewhere going, it becomes a crime. So it's the same approach of what of variables. So that's the first one, the local variable. And then we've got what we call a global what? Variable. In this case, usually it's defined outside all functions. It's defined what? Outside all functions. And its scope, or the scope of a global variable, it is the whole program, which means that it can be, that variable, it can be accessed by even everything, every method, whatever that is inside that class, it can what? It can access it. Unlike the local variable, you cannot, it's only, its scope is only defined in the what? In the method. You understand what I'm trying to say? It's only defined in the method. But with the global, it is accessed by what? By the whole program. So right now, I'm showing you what? The scope as well as the definition. And I'm trying to give you the scope as well as what? The definition. Very, very important for you guys to understand. Remember, we are talking about the C++ what? Storage class. And I told you two things that matters the most when you're dealing with the C++ storage class. Firstly, we can talk about its lifetime as well as what? As the scope. So here we are trying to define, when you're talking about local, global, we're trying to define its lifetime as well as what? As the scope. So with the global, the scope is just, yeah. So I don't think it would be important for me to show you on the code where a global variable is situated, but yeah. And then we've got what we call, or the third part, it's what we call the static local variable. The static local what? Variable. The static local variable, which is this one, the static local variable. So when we are talking about the static local variable, A static local variable exists only inside a function where it is declared, similar to a local variable, but if its lifetime starts when the function is called and ends only when the program ends. All right, with this one, it is the same as local, but the difference is its lifetime now. I believe we are all together. Now, the difference between the local variable and the static local variable is that it is its lifetime. Where we'll find it, we'll find it inside a particular function, or it will be declared in a particular function. But its lifetime, it starts only when the function is called, and it ends only when the program ends. So the main difference between the local variable and the static variable is that the value of the static variable persists the ends of the program, which means that it will stand until the end of the program. As long as it's called, it will continue until the end of of the program. All right. Thank you. I hope you caught the definition on that. I hope you caught the definition on that one. Right. And then we've got what we call the register variable. We've got what we call the register variable, which is this one, the register variable. So the keyword register is used for specifying register variables. So register variables are similar to automatic variables and exist inside a particular function only. It is supposed to be faster than local variables. If a program encounters a register variable, it stores the variable in the processor's register rather than memory if available. This makes it faster than local variables. However, this this keyword was discontinued in C++ 11, and it should not be it should not be used. So we will not look much into register and thread storages, right? But we will look mainly on the local, global, and static, right? So, and then as well, one thing that I would like to finish by is just to give you a definition of the thread local storage. So when we're talking about the thread local storage, it's a mechanism by which variables are allocated such that there is no instance of the variable per extent thread. So these two, they're not that important on our case, right? They will not be that important on our case. They will not be that important on our case. So what you must understand is the difference between the three: the local, the global, and the static. A question might come to say, all right, declare a local variable, declare a global variable, declare a static local, giving their definition. Or show or demonstrate your knowledge of the difference between these three types of variables. Very, very important for you to understand. Now, the last thing that I want to handle on this class, in this class, it is what I call C++ recursion. It's what I call C++ what? Recursion. Ever heard of something called factorial and all those kind of stuff? So we want to try and understand the logic behind that. So when we're talking about recursion, this is a function that calls itself. Let me repeat it. It is a function that calls itself. It is a function that calls itself. For example, if I were to ask you guys to say, how does what do you call this, factorial work? How does factorial work? It's just a question that I'm bringing to you guys. How does factorial work? Right. So factorial works based on what? On recursion, the calling of the function, right? If the function is calling itself, it's calling itself, it's calling itself, it's calling itself, it's calling itself. So I don't want to look deep into this, but just give me a moment. Just give me a moment. I want to see. I want to display something very, very important so that you can kind of get under, or kind of like understand what I mean by this recursion function. You see, sometimes assuming it can put you in danger. So it's better not to what to assume. It's better to just see what we can do. All right. All right. So basically, this is the what do you call sort of a syntax of how a recursion function works, right? How a recursion, it's a function that calls itself. As you can see, we've got a function here, and then it's calling itself inside and going down just like that. So it is a function that what calls itself. So let me just I want to show you an image. I want to show you an image. Hopefully this thing will allow me to explain the logic of, hopefully it will allow me. Hopefully it will allow me to all right. I believe you can all see the part of the screen, right? Just comment if you are seeing the part of this, the portion of the screen that I'm just showing. Just comment to say yes, we can see, so that I know whether to continue or not to continue. Can you see the portion of the screen? All right, yes, okay, thank you for confirming. Thank you for confirming. So this is how a recursive function works. As you can see, we've got void recurse, which is our function. Then this is a recursive what? Call. This recursive call goes back to the main function. Then as you can see, we've got the main method and then the function call. Where is it going? It's going back right there. So there is the recursion continues until some condition is what is meant. So to prevent infinite recursion, if else statement or similar approach can be used where one branch makes the recursive call and the other one doesn't, right? So that's basically how the recursion function works. But I want to show you something. I just want to show you something right now. Okay, let's say we've got this code, right? This is an example of factorial of a number using recursion. As you can see, we've got something that has been defined on top there, and then we've got int n, then the result, and then enter a non-negative number, and then result, and stuff like that. So I want you guys to basically look inside here. I want you to tell me, what do you understand by the code that is displayed right there? What do you understand about that code? Based on what, based on the example that I just gave now, what do you understand? There we go. We've got a code. We have defined our functions. Everything is sorted and all those kind of stuff. Now, I want you to understand, more especially, I want you guys to tell me this part. What is happening here? What is happening? Hello? Am I alone or what? Okay, seems as if nobody wants to answer, so you go and research about it. I cannot teach you everything. I'm asking you a question and then you're quiet. So it's it is fine. It is okay. It is fine. It's okay. Where is Munyaiti? Munyaiti, yes, you can talk.
Yeah, hello. I couldn't figure it out why the 10 variable now is one.
You're saying?
Like the
Please
10
repeat
value
what you're
is
saying.
now one. And I believe the formula you just marked is just a formula to compute the factorial. Pardon?
All right. We've got another answer that is from Mbongiseni. For any number that you put, it will be multiplied by the number and subtract 1 each time, which is true, right? So that's basically how this function works. So let me just display one last thing, then I shall let you guys go because I have sort of a meeting just now. All right. You see, this is just an example, an explanation of this is just an explanation of how the factorial program works. See, you've got result, and then there we go. And in fact, I will send you the notes so that you can actually understand from going up till down, because now I have to go and open that other tab, share that other screen, moving. So you will not really understand what I'm trying to say. But one thing that I will do, I will send the notes to the group so that you can go through them and try to understand how this recursion function. But mainly what you have to understand is a function that calls itself until a certain condition is met. So in the case of factorial, it will continue until it stops at what? At 1. As long as the number does not go below 0, it will continue to call itself, because you cannot have a factorial of a negative number. Factorials are only based on what? On positive numbers. So it will continue to what? To call the function again and again and again and again and again and again and again. The way you are seeing here, it's calling n is 4, n is 3, n is 2, and then let me just, and then n is 1. You see, when it will finally stop at what? At the last point now, because it cannot go beyond that. Because let's say if we are dealing with the factorial of a number, I believe it should be 4 times what? Times 3 times 2 times 1. So this is the same as 4 what? Factorial. I don't know if I'm making a mistake. I'm not a mathematician, but it has to be something like that. So that's how what recursive functions they work. It calls itself, it calls itself, it calls itself, it calls itself until a certain condition is met. After that condition is met, then it what? It stops. So guys, that's what I can say I wanted to share with you guys today. We'll have more examples as we continue, more especially on our next class. We'll have more and more and more examples. And regarding your test papers, you will get them very soon. You will get them very soon. And then, yeah, so that you can see how you actually worked on your test. But what I can say is that I'm a little bit disappointed by the performance of most of you. You guys were not really performing well, and I don't know why, but you guys were not performing well on the test. And yes, and yes. So I will I will yes, I will send the notes on the group, and thank you very much for attending. Those of you who joined the meeting late, you might as well as go to YouTube, and then you can just rewatch the whole class. I will save it that side. Yeah.